Here in section 2, we're going to take a look at applying congruence in triangles, building off of some previous ideas, i.e. the triangle sum theorem, as well as some other properties involving triangles. So, first of all, we need to understand what congruent figures are. Very simply, two figures are congruent if they have exactly the same size and shape. And so we've already talked about triangle similarity, and congruent triangles tend to be a little bit easier to understand. Each of their parts would match the other parts exactly, and we'll talk more about that as we look at some examples here. What corresponding parts, again, something we're already familiar with because of the fact we've already talked about similarity. The parts that match up, okay, are the corresponding parts, and if the figures are congruent, those matching parts or the corresponding parts have to be congruent to each other. Okay, so in example 1 here, it just simply says mark the angles and sides of the triangle below to indicate that the corresponding parts are congruent, and then we just got to list them. Okay, so again, if I know that these two triangles are congruent, A, B, C, and D, E, F, well then that tells me that angle A is congruent to angle D, angle B is congruent to angle E, and finally angle C is congruent to angle F. So those are the three things I know about my angle measures. So if I list them, okay, angle A congruent to angle D, B is congruent to E, and finally C is congruent to F. And now we can actually say more though. We can also look at the side lengths now. Okay, so if I look at the corresponding side lengths, AB corresponds with DE, so they have to be congruent. BC corresponds to EF, and AC corresponds with DF. And again, if we just write those as a statement, segment AB is congruent to segment DE, BC is congruent to EF, and finally segment AC or side AC is congruent to side DF in these two triangles. All right. Example 2, again, it's the same idea. I'm not going to do this example again. You can do it on your own, and if you have issues with it or have questions about it, obviously bring those to class and we'll take those. Okay, example 3, now we're going the other way. So they give us two figures that are congruent. We have to write the congruent statement. So really all you have to do here is identify your corresponding parts. I think it's pretty obvious here that A and F correspond because they're both right angles. Okay, angle B is congruent to angle G, so those are corresponding, and then C and H are corresponding. And so finally, when I write my congruent statement, if I look at the triangle here at the left, I'm going to call it triangle ABC, and if I say ABC, then the way I name the other one, things better line up here. Okay, so angle A corresponds to F, so F has to go first. B corresponds with G, and finally, C corresponds with H. Okay, so we just got to make sure that all your pieces match up. Example 4, we're going to use this idea of congruent figures. So if we know that these two quadrilaterals are congruent to each other, example A here, or part A I should say, says find the value of X. So the way I see this is I look at this diagram and I realize, okay, X is here in angle W. Angle W corresponds with Q. And so I can set up an equation. Now I can set up the equation 5x plus 5 is equal to 65 here, and that's going to allow me to isolate x. Okay, so now I just use my algebra skills, subtract your 5 from both sides. So 5x equals 60, divide by 5. And that tells you that x equals 12. Okay, I don't know why I crossed out 60 over 5. All right, part B says find the value of y. Okay, so now once I know what x is, I can plug it in over here. So the length of wx is actually y minus 12. And again, it all goes back to look at your congruent statement. Wx corresponds with qr. Qr is 6. So qr and wx have to be congruent. And so now I know my equation is very simply going to be y minus 12 equals 6. Add your 12 to both sides, tells you that the value of y in this example has to be 18. Pretty simple stuff once you understand what congruent figures are. Okay, we are not going to look at example 5. Okay, third angles theorem. We've actually already mentioned this in class. All it says is that if two angles of one triangle are congruent to two angles of another, then the third angles have to be congruent as well. So in the diagram, we know that A and D are congruent, B and E are congruent. Therefore, we can conclude, without knowing the actual angle measures, that angle C and angle F have to be congruent by the third angles theorem. So example 6 says find the measure of angle V. Okay, well here's what I know. I know that this angle and this angle are congruent. I also know that my two vertical angles in the middle are congruent. And so now if I look at the triangle on the left-hand side, triangle STU, I can find the measure of angle S by using the triangle sum theorem. So 66 and 44 makes 110. So 180 minus 110 tells me that the measure of angle S is 70 degrees. And again, by the third angles theorem, okay, 66 and angle W are congruent. Your two vertical angles are congruent. So your third angles also have to be congruent. So angle V here has to have a measure of 70 degrees based on the third angles theorem. And then example 7 here, we're looking at a proof. I know on yours it obviously doesn't have all the fill in the blanks. So if you want to ignore the video for now, pause it and try to write the proof on your own, great. If not, we can kind of go through this argument here together. So statement 1, obviously reason 1 is always what you're given. Okay, so just write down your given information. Number 2, we're using the reflexive property, so I have to identify a piece that is in both triangles at the same time, and that piece here happens to be side GH. So all I'm going to say here is GH is congruent to itself, and that's based on the reflexive property. You don't have to say reflexive property of congruence. Reflexive property would be fine here. Reason number 3, okay, let's take a look at, so we're looking at FHG. FHG is congruent to JHG. All right, and I mean that's information that we already knew. Okay, so that's given to us as well. I probably should have just included all of this in statement number 1 as opposed to having two separate givens there. But anyway, so once I know that I have two sets of congruent angles here, that automatically means that the third angles, angle F and angle J, have to be congruent because of the third angles theorem, what we just looked at in 2 slides ago. And now finally I can say that the two triangles are congruent because I've now shown that all corresponding sides and all corresponding angles are congruent. So I can say that they're congruent by the definition of congruent figures. And as we get going here, the next few sections, we're going to actually look at shortcuts for proving triangles are congruent, so you're not going to have to show 6 different things, very similar to what we did with triangle similarity. Okay. All of the properties we've discussed regarding numbers and segments and angles also hold true for triangles. In other words, the reflexive property is still there, so triangle ABC is obviously congruent to itself. If triangle ABC is congruent to triangle DEF, then we can say it the other way as well using the symmetric property. DEF is congruent to ABC. And of course, we have the transitive property. So if ABC is congruent to DEF and DEF is congruent to JKL, then that just simply means that ABC and JKL have to be congruent to each other. So again, properties that we already know shouldn't be an issue. And finally here in example 8, we're going to take a look here. They tell us that E is the midpoint of AC and BD. Okay, and they want us to show that those two triangles are congruent to each other. So we're not going to write a formal proof here. All we're going to do is kind of talk through this, and hopefully you kind of catch on here and figure this out. So first of all, I'm given some information here. I'm given that these two sides are congruent and parallel to each other. As I've said all along, if I tell you that two sides are parallel, you're going to use that information. So in this particular diagram, the way I'm going to use that is I'm going to say that angle B and angle D are congruent because they're alternate interior angles. By the same argument, I'm going to say that A and C are congruent, alternate interior angles. And then obviously, I think we all see vertical angles pretty clearly now. So you have your vertical angles are congruent. So far, what I've shown in the diagram is that all of my corresponding angles are congruent. So now I have to turn my attention to the side lengths. I already know that A, B, and DC are congruent. They told me that. So now I have to try to figure out how I can show the other sides are congruent, and that obviously is going to take us right back to the information we were given. I know that E is the midpoint of AC and BD. So by definition of midpoint, I know that AE and CE are congruent, and I also know that BE and DE are congruent. Okay, so again, I'm not going to write this all up in a formal proof or even write a whole lot out, but all of that, what we just talked about, shows you that the two triangles are congruent. As we get going in the next couple sections, you're going to have to prove triangles are congruent, but in this one, it's just more about understanding what it means for figures to be congruent. So, as always, any questions you might have regarding any information presented in this section, have them ready to go in class, and we'll make sure we clarify things